Welcome to Lesson 5C. In the next preview assignment and in the next class, you will need to calculate a weighted average to combine results from different polls. Splitting a whole into parts by percentage. Splitting a whole into parts by percentages. Weighted averages, and again, you need to have some kind of glossary or flashcards, Google Docs, something running where you have a collection of your words and processes. Weighted averages are used when some numbers in a data set are more important than others for the final average. At least get the weighted average definition started. You can add this sentence, write it down. You're going to have more when you do 5C in your 1332 class, but this is a great place to start. We often say that these more important numbers are weighted more heavily than the others. When calculating a weighted average, the first task is to determine the weights for the numbers. These weights are often expressed as percentages. Again, really good information to have on a weighted averages area, glossary, card, something. In particular context, there will be good reasons to choose certain weights for certain data points. But one rule that must always hold is that the weights must always add up to be 100%. That is a great detail to put on a weighted averages card or a glossary. When we distribute the weight amongst the members, we have to distribute all 100% of the weight. Now it's time for you to hit pause and you go answer question 1, maybe question 1 and 2, or questions 1 and 2. At least answer question 1 and then come back and we can walk through this together. It begins by saying, let's explore splitting up a whole into parts by percentage with an example. You have Carrie, Jacqueline, Nicole, Dorsey, and Nathaniel are all working on a group project together. They estimate if one person did this project alone, it would take one person 15 hours to complete. Part A, if the 5 group members split the work up evenly, how many hours of work will each person do? How many hours per person? Writing words is always a help, a guide, something to help us know where to get started and then to check reasonableness when we get done. So how many hours? Well, if we know the project takes 15 hours and we have 5 people, this would get us 3 hours for every one person. Looking at part B, if the group members split the work up evenly, what percentage of this work will each person do? This one may be a little interesting as to how it is asked, but we're going to go a different direction because it is saying percentage. We have been working on a reference value, and if it wants to know what percentage of the total work, then that means the total work is 15 hours. But it asks what percentage of the total work will each person do, and if each person is doing 3 hours, when we reduce or make this into a decimal and multiply it by 100, we find that each person will do 20% of the work. If you haven't already, go ahead and hit pause and go complete at least part, if not all, of question 2, and then come back and we'll work on it together. The group decides some of the students will do more work for the project than the others. Carrie is going to do 50% of the work, Jacqueline 20%, and Nicole and Dorsey are each going to do 10%. Nathaniel is going to get what's left over, what's not but done by everyone else. So what percentage of the work will Nathaniel do? Lots of different ways you can go at this, but a way is if Carrie's going to do 50%, Jacqueline do 20, Nicole 10, and Dorsey 10. We've got 50, 60, 70, 80, 90% of the work will be done by these people. So 100% of the work still needs to be done. That means Nathaniel is going to do 10% of the work. The following table lists the percentage of the total work that each person will do, and recall the total amount of work to be done on the project is 15 hours. Fill in the third column with the number of hours that each person will do, and you're going to need to put in Nathaniel's percentage. So here are the weights. 15 hours is the total job. We have a couple of things to do. First, let's fill in Nathaniel's part. Remember that all of this must add up to be 100%, 50, 60, 70, 80, 90, 100. And then on the total hours of work to be done, or at least per person, Carrie is doing 50% of the work. That's 50% of 15 hours. When we multiply these two together, we find out that Carrie will do 7.5 hours of work. The next weight, or 20%, the percentage, is still 20% of the 15, the total work hours. And this comes out to be 3 hours. The 10% times the 10%, we get 1.5 hours, 1.5 hours, and 1.5 hours. It's always good to double check your work, because this lends itself to saying if I had 7.5 and adding in these other hours like 8, that would be 9, 10, 11, 12, 13, 14, 15. It's pretty fast and easy to check. Our 15 hours are still there, and we have used the weights to determine the hours to be worked. If you haven't already completed question 3, go ahead and hit pause, complete question 3, and then come back and we'll work on this together. Also, remember, you can pause and start this video as much as you need to make it make sense, to make it clear. And the thought even came to mind, you could take this with you to tutoring and help them walk you through the pieces and parts of the information. We have tutoring centers all over our system, and your tuition and fees have paid for you to receive that service, at this point free of charge. So look with me at question 3. In Shakespeare's tragedy King Lear, the elderly king decides to divide the island of Great Britain evenly between his 3 daughters, Regan, Goneril, and Cordelia. Let's imagine that instead of dividing the kingdom evenly, King Lear divides Great Britain as follows. Half is going to go to Regan, 1/3 to Goneril, and the rest to Cordelia. Great Britain has an area of 209,000 square kilometers. Complete the following table using the information and round to the nearest tenth of a percent in the second column and to the nearest 1,000 of a kilometer square in the third column. So talking about percent, let's start with that. Regan was half, so that's 50%. Goneril was, where is that? 1/3. So 33.33%. What was I supposed to do? Nearest tenth of a percent in the second column. So officially I should have said 50 and no tenths. And then Cordelia received all of the rest. So we need to calculate what's all of the rest. So if we have 50% and 33.33%, and we add those up and we subtract those from 100, I'm getting that we get 16 7/10 of a percent. So I followed the rules, 1/10 of a percent in the second column, and then we're going to go nearest 1,000 kilometers squared in the third column. So let's grab a different color. And again, you got to keep going back and forth. What are we even talking about in this lesson? And it started out by saying there are these things called weighted averages. And we keep dealing with weights, different weights. And then we're using those multiplying times a value. In this case, it's 209,000 kilometers square. I'm going to go ahead and use the whole 209,000. I'm going to multiply, and it says to the nearest, where is it saying? The nearest 1,000. So when I multiply, I actually get 104,500, but to the nearest 1,000, that's going to be really 105,000 1,000. But for this column, the way it is written already in thousands, all I need to write for this final answer is 105. We'll repeat the process. 33 and a third, 0.333 times 209,000. When I multiply these together, I'm getting 69597, and that's going to be about 70,000 kilometer squares. But in this box, we are supposed to only write this in terms of thousands, so I'll write 70. So 105 on the first, 70 on the next, and then finally, we multiply the last one times 209,000, so it's 0.167 times 209,000, and I got 34,903. Rounded to the nearest thousand, that 4, that 9 makes my 4 go to a 5, so I'm getting 35,000, or to answer this one correctly, 35. A quick add of our 105, I need to do it up here. Remember, double checking, reasonableness, those are always great ideas. 105, 70, and 35. Getting 10, 11. I'm getting 210,000, and really it's supposed to be 209,000. That is very reasonable because I rounded here, and I rounded here, and I rounded here, and that's going to throw our answer off just a little bit. One more time in this lesson, you need to go ahead and hit pause, complete all of question 4, and then come back and we can work through this together. I'm looking at question 4 that says the following is a screenshot of the data from question 2 entered to, the data is in Microsoft Excel. I'm going to keep reading in your worksheet that says note that column B is formatted as a percentage. This means that while the values in the column are displayed as percentages, they are stored as their decimal equivalents. For example, while B3 is cell B3 is displayed as 20%, the value of B3 in the spreadsheet is actually 0.20. Part A. The percentages of a whole must add up to 100%. Check that this is the case. Enter into cell B7. Where's B7? This would be B7. What would we enter into B7 to check to see that all of these are adding up to 100%? Well, remember, Nathaniel was 10, and so we can say equals sum. And when we do the sum, we want to get what information is in B2 and sum or add it all the way down to B6. When we hit return, since these are stored as decimals, we should see that we get 1. And 1 is the decimal value of 100%. And this means we did it. Part A, the percentages must add up, and we checked it. And to explain the formula, the equals tells us we're working on a formula. We're going to do some math. That means to add up information. That's our starting number, our ending number, and the colon is from here to there. Moving on to part B. Which cell contains the value of the total hours of work done? That would be this cell here, which is C7. They would like for us to read this before moving on, and so let me go ahead and go to that screen. Sometimes we want Excel to use the same value from the same cell in a series of calculations. To do this, we have to use what is called an absolute cell reference. This is accomplished by placing dollar signs around the label for the column. For example, in the table above, an absolute cell reference for the total number of hours is, as you see here. There is a shortcut. Very likely you can just use $7. Be aware of both. Practice so that you can practice and use whichever one works or is needed. Part C, what formula would we enter into cell C2 to compute the hours of work done by Carrie given her percentage of work done? And your formula use an absolute cell reference, the dollar signs, to the cell containing the value of the total hours of work done. That's the one that's got our 15 in it. So let's go back to the, uh, the display. What they're asking us to do is to write the formula of what we would put in this cell, C2, by taking Carrie's percent of work that she's going to do and the total number of hours, and they would like for us to use an absolute cell reference. So inside this cell, we want it to say equals. We are wanting to do the 50% of the 15 hours. So the 50%, if you will recall, I can put in B2, and I do not need to divide it by 100 because it's stored as a decimal, so it's going to come up as 0.50, and then I'm going to multiply it times. I'm going to multiply it times. I want to nail down that it's a 15. I always want to use 15. I don't want this to change. I want it to be that cell and not to change. So I can put a dollar sign, and the cell is C $7, and that will lock it in. We could also do equals B2 times, sorry about that, I should have used an asterisk, C $7. We could use either. Practice using these in your Excel spreadsheet. This completes our lesson 5C. Look at your calendar to see if you have more assignments due this week, and I'll see you again in another lesson very soon.